Welcome to Insight Builder channel. Large language model automators, AI enthusiasts, and Python experts. Weaviate explained. Connecting Spark pipelines to Weaviate. Creating Spark ETL pipeline to Weaviate inside Jupyter Notebook. The challenge solved in this particular discussion is vector storage. The big data is inside Spark warehouse or any kind of warehouses, while Weaviate needs vectors of that particular big data to be stored inside Weaviate vector store. And this activity is what we are going to do in this particular discussion. So we are going to move the data from the Spark environment or the warehouse into the Weaviate instance. For that, we have a couple of options available. First and foremost, Weaviate team by themselves have created a Spark connector. This particular Spark connector needs some of the dependencies to be resolved. That is, Java version as well as the Scala programming language needs to be installed. That is, the compiler and the interpreter of that language has to be installed in the system that you are running. In my case, when I was trying to get this thing up and running, my connector started throwing an error. It was telling that a particular method is not found. So I am doing the research in the background on how to resolve this particular challenge. However, see, the idea of this particular video is to get the data from the big data storage into the vector store. For that, one of the options is Spark connector, but still we can use the knowledge that we have gained already about Weaviate, and we can actually manually move the data from the Spark warehouse to Weaviate. So that is what we are going to see. So what you are going to see right now is actually a little more elaborate process of what this Spark connector will do it very easily for you guys. So you are going to learn something really more important, because Spark connector will actually abstract it away, right? So I will show you how it does. So you will see what is exactly being to be done for getting the Spark connector up and running. But yeah, you can also try it out in your environment and see how it works. But let us see that without, even if the Spark connector is not there, how to get the things done. Apart from this, also I would like to share some credits to Weaviate team. That Weaviate team has worked a lot on Sphere dataset. The Sphere dataset has been released by Facebook, which is a really huge dataset. And this particular dataset, which spans almost 900 GB of data, that is having a lot of information in the internet collected in a single place. We as regular users getting to work with such a big data is not really feasible. So let us put it that way. Why I'm saying it's not feasible? Because even if you have to download all the data, load it in your system, start working around it, it's going to be taking a lot of time. But Weaviate guys have done all this activity for us, and they have given us a set of data sets that we can work with. And among those data sets, we are going to take a data set which contains 100k rows, and we are going to work with it. So that is the one point. And the second point is the data set, which the Sphere data set actually has its own vectors, and that particular vector is created using a Facebook model. So that model also will be discussed. And always be ready to take a new route anytime, because see, as I was trying to work out this particular discussion that we are having right now, so initially I was thinking, okay, it's going to be a pretty simple activity, so I will just put this presentation together, get the Jupyter Notebook running, and get over with it. However, I had to learn a lot of stuff. So be open for such learnings, and also it took considerable amount of time. So what happens is, whenever any kind of these abstractions, like Spark connector is an abstraction that is working on reducing the number of lines of code that you can write. That is the intention of Spark connector in this particular place. However, when such things are not working appropriately, then you need to exactly know how to get the things done. So that is one of the points that I always iterate, and for that only I always say that you need to practice a lot. The more you practice, the better you can visualize how to solve the challenges that is in your hand, and then save the day. I hope that you like this content. Do leave a like, share it with others, and subscribe to my channel for further updates, not just on large language models and artificial intelligence related details. I have a separate playlists on big data also. So that's where I got interested. I already have a series which discusses about getting the Spark environment up and running, and to practice Spark related ETLs, working with the DML and DDL activities. That is a separate ecosystem on its own strength. While this particular domain of large language models, the vector stores, how the large language models are powering up the new revolution that is starting right now. It is in the beginning of a different kind of an era where the search is no longer constrained by the particular server. So everybody can search their own data at a rapid pace, and that too without a lot of logic. So by using simple English sentences, that is natural language, we can get a lot of data out of our own data. With that said, I would like to go to the browser. As I was telling, I have various other playlists. Among that playlist, Hugging Face, that is Mastering NLP with Hugging Face playlist, has the discussion related to Weaviate. Not just Weaviate, it also has discussion related to other related libraries in Python, like TXTI, Unstructured, and 2V. There are considerable amount of different Python libraries that work with large language models, with vector stores. So it's not just Weaviate, and it's not just Fies or ChromaDB. So there is a slew of options available. That is what I wanted you guys to actually take a look at this particular playlist. You will get a good idea. For this particular video that we are going to discuss, you can better take a look at these two discussions, that is exploring Weaviate and Weaviate explained, understanding schema and querying. We will be using the knowledge that we have taken from this particular video, and we'll be using it in this discussion. So that's the reason why I'm insisting that take a look at this. With that said, let us actually go to the details that Weaviate team provides. Most of the code that I am right now going to discuss is actually taken from this particular blog post that has been shared by Weaviate team, and they introduce Spark connector in this particular blog post, and they also discuss about this Weaviate Spark connector. This is one of the Spark connectors that they discuss, and they have explained how to use it, which anyway did not work in my case. And this is the set, the chain of methods that we need to use to write this Spark data frame. Just let me zoom in so that you can see better this particular data frame to Weaviate instances. So Weaviate instance that is running in localhost 8080. This is something that I tried, however, it has its own challenge, but do read this blog, you will get a lot of information. And also Weaviate team explains how they worked on this sphere dataset in this particular blog post. So I will be providing you all the links in the what is it called, in the repo in the repo Jupyter Notebook. I'll be giving all the links that we are going to discuss. So this link for this particular Jupyter Notebook will be attached in the YouTube description. So take a look at that and start working with that. Now let me close these windows so that we can concentrate on the code. So to begin with, as I was telling you, I started to concentrate on connecting Weaviate client and PySpark and move the data. So that was my initial starting point, right? So for that, I had to do, I will be introducing that steps also. So first and foremost, I need to install PySpark. And once we install PySpark, we need to know where to copy the jar files. So in order to do that, after doing some research in Stack Overflow, I found that we need to place the jar file on this particular path. So that is the key point. To download the jar file that is suggested by Weaviate team, we have to go to Maven, and they uploaded it in Maven location. So that is one thing. Actually, the Spark jar files are in the Spark. There is a separate repo to which, if you call config spark.jars, just a minute, let me zoom in a bit so that you guys can see it better. So if I just use this config spark.jars and this particular Weaviate, this particular connector jar file, if this particular jar file is uploaded into the Spark jars database, then it will automatically get pulled. I or you don't need to do anything. We don't need to move these files like from this particular, after downloading it from this particular Maven, we don't need to move it manually. However, Weaviate team is yet to upload this particular jar files to the Spark jars database. So it's not yet done. That is one thing. But even if we get a hand, get our hand on this Spark jar file, still even then building a Spark session using that jar file was still not getting the things done. So in my case, at least it was not getting the things done. You guys can try it. Do leave a comment if you have succeeded it. I will be glad to know how you did it, and I will try to recreate it and see how to recover my errors. With that said, the data set that you are going to use is also shared from the blog post that I showed it to you a couple of minutes back, where Weaviate actually shared the links. Weaviate actually shares the links for lots of other data sets, which is actually pretty huge. 100K dataset is the least size, and I am going to untar it and work with the actual JSON file. Reading it into Spark environment using the Spark session is straightforward. I have to just use the load method to read the JSON file using the format JSON. That is first step. So I have read the JSON file into data frame. So just to show you guys what is there, really, I am going to use a df count. So that will tell you how many rows are there inside the data frame. However, don't worry guys, we are not going to sit and wait until all the 100K rows are going to be vectorized and then stored into Weaviate client. I'm just going to show you only 5 rows. So this is the 100K data that is already available, that is already loaded. So you can take this particular data, this particular Jupyter Notebook for your experiment. So no issues in that. Next, what I'm going to do is I'm going to use an embedded options, because embedded Weaviate instance options. Why? Because I'm using Jupyter Notebook. Jupyter Notebook, it is better to use the embedded options. If I try to create a separate instance and I try to connect with it, there will be lots of additional shenanigans I should do to get the things up and running. Thanks to Weaviate team, I don't need to do that. So that is how we are going to use embedded options. Once we do that, I am going to create a new data set, that is data frame. I am going to take only the 5 rows of the data frame, the main data frame. This is what I'm going to work with. This is something that we are actually moving into the next step, where now we know the data set. We have the 5 rows with us. So let me actually do one thing. Let me show you what is there in the data set, because I have not shown it to you till now. I'm going to do a show here and I'm going to execute it. You will see that it has got these are the columns that is available. So we have ID, we have raw, that is the raw data that is available. We have the checksum, we have the title of that particular raw data, and we have the URL from where they took it, and it also has got the vectors. This is where the things are going to be a little more interesting. I was telling you that we will be discussing about the Facebook model that actually helped you to create this vector. So I'll be discussing that in a couple of minutes. But also we will discuss how to load this vectors also into the Weaviate instance. Okay, let me move to the next step, and then I will explain to you what will happen in the Weaviate instance. Usually, before we have to create a schema before we start loading the data into the Weaviate instance. So Weaviate instance is like a database or a database server, which will have a lot of classes. Classes are basically indexes, and indexes, the right word will be, let us go with indexes only. So there will be multiple indexes inside the instance. It is equivalent to tables inside the database, the regular database, right? And before we actually create any database, once we create the client, this particular client, Weaviate client, we always delete, just to ensure that there is no any residual schema or any error to pop up. We delete all the schema, and then we start creating the class. When you create the class, you provide the name and then you provide the properties. The properties contains the column names, that is the column names and the type of the data that is going to go into the particular column. So all this discussion has been already done in the earlier video. I will link that particular video to this discussion also. So take a look at the earlier video. I already shared you the playlist, right? In that I had discussed about the data retrieval aspect of Weaviate. So schema and querying. In that particular video, I have discussed this in detail. So if you see in this particular schema creation, there is the vectorizer. So I'm just calling the vectorizer, and I'm telling text to vec Hugging Face vectorizer needs to be used. I'm not telling anything about what is the model here. So this is the very basic way of initiating a schema, and the vectorizer model etc. is decided by Weaviate itself. It will use the by default it will use Facebook, one of the MS Marco model, and that is how this particular vectorizer will work. This is a very basic thing. And once you create the schema, as per the Weaviate tutorial, what we need to do is we need to use this series of methods, and then we need to write the data frame data that you see here, that I limited it to 5. Weaviate team has limited it to 1500, and they change the column name, and then they write it to the Spark Weaviate connector. So this is what they are doing, and in the Spark Weaviate connector gets a lot of information like batch size, scheme, the host, that is the Weaviate instance host, the class name, the ID, the vector, even the vector. So I showed you, right, the vector that is available here, that also can be returned manually, and then you actually write it to the Weaviate instance. However, if you execute it and if it works, it's a good thing, but if it doesn't work, then we have an alternate that we are going to follow. That's where the things get interesting. So this is something that I give the step-by-step. Weaviate team has given the step-by-step idea or the concept of embedded Weaviate instance, what actually happens in the background. This is actually something that you guys have to know to understand the life cycle of the Weaviate embedding instance and how to work with it in Jupyter environment like Collab notebooks. That is the first thing. Second thing, I wanted to introduce you to the links that are available for the Spear dataset and the Hugging Face link for the DPR question encoder single question base, NQ base. So this particular model is used in the Spear dataset. So this is also available introduced by Facebook team, and this is actually a Facebook model only, and they use this for creating these vectors. So these vectors were created using this particular model, and you can read a lot about this in this particular Weaviate blog also. The point I want to make here is that once we create the schema, okay, you can actually load it like this, or if this doesn't work, then we can use the regular method. The regular method is that we use the iterator. So we create a iterator. This is the important part. So I create an iterator for iterator in new_df.collect. This part is actually an iterator. It will not load all the data into the memory by default. Only when the memory is called, the data is called, then it will load the data into the memory and write it to the sink, that is Weaviate instance. This is the process that we see, and you will notice that there is batch size. So you take a look, there is batch size, and there is scheme, there is localhost, and there is class name, and there is vector. So you see all of these things are here also. There is batch size, you see the batch size, you see the scheme that is going in, and you see the class that we are providing. So it is very similar to what the connector has been written by Weaviate team. And also, if you had expected something different when it comes to working with Spark, I'm sorry about that. Working with Spark is very similar to how you work with the rest of the primitives, class primitives inside Python. You will use a simple loop over the data frame collection. This data frame becomes a collection, and that or a collection or iterator, and that iterator we are going to enumerate, and we are going to load the data into the Weaviate instance. So this is something, it is straightforward. Once you do this loading, what will happen is, based on the schema that you created, here we did not give any kind of Hugging Face model name. We just told that the vectorizer is going to be Hugging Face. So by default, it will choose a default model, and it will do the iterator. Sorry, it will do the vectorization of the data. What we are going to do right now is we are going to create a new class. In this new class, we are going to specifically mention that we want to use the sentence transformer all MNLI mini LM L6 V2. So this we are mentioning it in this particular location under the module config parameter, and then we are going to give the same properties and the same process we are going to follow. So here I have changed the vectorizer. You see that I'm going to do that, and again I'm doing the same thing. So I'm going to load this particular Spark data frame as collection, as iterator, and I'm going to iterate over it, and I'm going to load it into Spark, the Weaviate instance. And after that, I'm going to do the near text search, and you see that, just a minute, let me do the near text. So once I do the near text search, you see that I get the nearest text to Clear Creek Chapel, and you might be wondering, okay, this particular text has nowhere relation to Clear Creek Chapel. Why did I get it? Because I have given a limit of 2, right? And the first output is what is very close to the concept that I'm asking, and the second output is actually the second best, and second best can be the the last worst also. So the way vector search works is by finding the approximate nearest neighbors, not the exact search. Unlike the Google search or any other search algorithm that you guys might have come across, the approximate nearest neighbors will not directly zero in on the particular target query or particular target sentence or text snippet. It will work around the target snippet, and there will be multiple neighbors. So that's what you are seeing here. Next, what you are going to do is, this is the model I was talking about. So this is the model that is getting used, and I am going to create one more class here. But see the difference here. I am going to create this particular vectorizer with the class called page, and I am going to use this options, and you see the properties, I am not giving anything. However, if you go up here, I am giving all the properties clearly here, right? So there are two ways Weaviate works. One is that I can provide the properties, or I can let Weaviate to choose, that is auto generate the schema. I'm going to use that option in this place. This is part of the Weaviate blog only. So this is not something that I am doing it myself. This is part of the blog. And the difference I am going to show you here is that when we are going to load this particular model, this particular schema, the schema will be created inside the Weaviate instance. And then when you are going to process it, the only difference here is that we are going to send the vector also. This is where the actual difference arises. So what this means is the Weaviate instance or the schema is not actually doing the vectorization in this particular step. The vector is already loaded by the user, that is you, into the Weaviate instance. This is also possible. So this is one of the important points I wanted to share in this. I am still using the same data frame. I am collecting it as iterator, and then I am loading all this information as properties. Okay, you might be wondering, Kamal, how did you know that you need to put the properties like this? Okay, the point of the schema is that schema will only allocate the type, the name and the type of the data. So we know the name. The name is going to be pulled from the column name that is already provided. So that is going to be done by the auto schema process in Weaviate. But the data type is not something that we are going to create. So it will get automatically created. So for me, the process will be same. Whether I am going to use auto schema or no, I have to still use the same column names to read the data and then assign it to the properties. This is something we can only understand if you follow the manual process. So once you do this manual process, sorry for going up and down. So once you do this manual process, then you will know, okay, so this is how you need to load for the auto process. And this vector data that I'm providing here, you see the difference. I am not doing anything here. I am actually providing the vector when I'm adding the data object. This is the difference that you guys have to understand. The reason, so you might be thinking, Kamal, why are we giving the vector here? And again, why are we giving the vectorizer here? The purpose of giving the vectorizer here is the schema will still need to query, take the natural language query from the user, and it has to do the modification. It has to create the vector of that query, right? For that, it still needs the model. That is why we are giving this model here. And once I load this model, what we are going to do is, you see this, I am going to use the same Clear Creek Chapel concept, and here I am going to query the class page, and I am going to use near text method with near text method, and you see that I get the output. So sometimes understand one thing, this particular concept that is getting given by the user here, it is natural language, right? this particular natural language input needs to be converted to the vector. That conversion is done by this particular model. This is what I want you guys to clearly understand. Okay. After you do this, you will see that you are getting the output, and you might be thinking, Kamal, the output is still same. What is the difference of using the Facebook model and using the what is it called, sentence transformer output? For that, you guys have to really go deeper into the way this Facebook model has been created. The Facebook model is specifically created for question answering, and while the sentence transformer is created for the regular what is it called, regular vectorization or encoding. And the second point is Facebook model is tuned in such a way that it can extract the features out of the data that is provided, that is natural language data that is provided to it, and then encode it. These are the benefits that you get by using specific models. And okay, further, you might be still thinking, then why are you introducing us to this sentence transformer in first place? We don't need to know about this. The reason why I'm introducing you this particular process is that you guys have to understand that it is not only going to be Facebook model, or it's not only going to be sentence transformer. There is going to be many other models and many kind of data sets. And in case of big data, there is going to be a lot of different versions of data also, and media type also. So tomorrow, if you are going to encode a video which is stored inside some of the big data network, you should still be able to use a very different kind of a very different kind of a model to encode the digital data that is coming from the video information that is available. For that kind of understanding, working with different models, trying to break the example, as I always say, is very important. After you do this, so now we see that we can actually work with the Sphere data set. We can work with the PySpark, creating the ETLs. So now working with PySpark or working with regular Weaviate instance is as simple as working with any of the Python primitives. So it is not very different. But only when you see the challenges that you are going to face when you are going to work with Spark environment, this can be clarified. So if I blindly say that it's same, then you might be still wondering, then what is the difference of using PySpark? That's why I had to clearly explain what are the challenges and then how to solve it. With that said, I would like to close this particular discussion on the code, and let me go back to the PDF. I hope right now that you guys got the overall idea of how to work with PySpark, and how to bring the data from PySpark into Weaviate instance, and how to work with the vectorizer encoders, that is various open source models that is available inside Hugging Face, and vectorize it. Also, we saw that how to load the existing vector data that is already available inside the dataset into Weaviate instance. All of these points we discussed in this particular video, and it is going to be very overwhelming. When you start looking at a couple of the videos, there is a high chance that you might get confused. The moment I initiate a video, there is a clear challenge. But once I cross the challenge introduction, and once I enter the solution space, where I start discussing the code, and then the things becomes little blurry. So you guys may not have still noticed it. When I watch a lot of YouTube videos, I face this challenge. So the particular author or the explaining person starts with the challenge, and then explanation starts, and suddenly we lose the thread of the explanation. Sometimes even the explainer, like me, might lose the thread completely. So in order to regain the bearing, one of the options that I always use is to watch the video again. The another option is to directly take the data or the code that is provided by the explainer, the YouTuber, and start trying it myself and doing the research also parallelly when the video is running. So in that way, what happens, I get a lot of additional knowledge, and also I can understand the pitfalls that the YouTuber, the explaining person, might have already faced. So these are the things that you guys have to think about. I hope that you like the content. Do leave a share, do share it with others. Subscribe to my channel for further updates related to not just large language models, but also about the various Python ecosystem and big data ecosystem. And you have seen right now that two different, extremely different domains like big data and the vector stores are getting merged together very easily, because if you know PySpark, then it is going to be a breeze. And if you understand Spark and if you understand how the big data ecosystem works, then you will be more confident to work with massive data sets like Sphere dataset and start working on real world challenges with vector stores that involve Weaviate, FIS, ChromaDB, and there are very many other options also. So do a lot of practice around this vector stores, because that's going to be a very big technology going forward. With that said, I would like to close this video with always the 4 words, that is practice, 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 practice. See you guys, have a great time.